If A is 3, 1 minus 1, 2, then show that A square minus 5A plus 7I equal to 0 and hence find A inverse. Now here I want to emphasize, when it is written hence find A inverse, sometimes what happens, the students, they will work out A square minus 5A plus 7I equal to 0 matrix, fine. But then they will find A inverse by the usual method of finding A inverse, that is 1 by determinant A into adjoint A, and that is not accepted. When it is written hence, that means using the relation A square minus 5A plus 7I equal to 0. Using this you find A inverse. We'll see how to do that. So let me first of all prove A square minus 5A plus 7I equal to 0. For that, let us first work out separately A square minus 5A and 7. What is the given matrix A? It is 3, 1 minus 1, 2. So what is A square? A square means multiply the matrix A, that is 3, 1 minus 2 with itself, again 3, 1 minus 1, 2. Now both the matrices being of the order 2 by 2, you know, the product will also be a matrix of order 2 by 2. By now you know short how to multiply the elements of first row to be multiplied with the first column. So you get 3, 3, 9, 3 into 3, 9, and minus 1. 1 into minus 1, 1. And then 3, 1 multiplied by 1, 2 gives you 3, 3 plus 2. And repeat the process with the elements of the second row with the first column and second column. You get minus 3, minus 2, and with the second column you get minus 1 plus 4. So work out, we get 8, 5, minus 5, 3. Call it, say, second. Let me call the given relation to be proved. This relation, that is A square minus 5A plus 7I, which we have to prove, let me call it equal to 0, we have to prove. Let me call this as 1. So this is 1, and we have to prove 8, 5 minus, and now we have got the value of A square equal to 8, 5 minus 5, 3. Now what else you want? You want minus 5A. So let us work out minus 5A, that is minus 5 times, what is A? 3, 1, minus 1, 2. Multiplying by minus 5 to each element, you get minus 15, minus 5, and minus plus 5, and minus 10, call it 30. Then find out 7i. 7i means 7 times identity matrix of second order, because the given matrix A is also of second order. So 7 times 1, 0, 0, 1, that is 7 times multiplying by each element by 7. So this is equal to 7, 0, 0, 7. Now call it 4. Now when we have worked out A square minus 5A plus 7i, let us add them. So from 1, the left hand side is A square minus 5A plus 7i. Replacing the values from second, third, and fourth. You get A square, we worked out as 8, 5 minus 5, 3. The value of minus 5i directly we worked out minus 15 minus 5, 5 minus 10, and that of 7i is 7, 0, 0, 7. All the three matrices of order 2 by 2, we can add the corresponding elements. So by addition, you get 8, 8 minus 15 plus 7. Then you get 5 minus 5 plus 0, minus 5 plus 5 plus 0, 3 minus 10 plus 7. So you get 15 minus 15, 0, 5 minus 5 cancels, you get 0, 5 cancels, you get 0, and here you get 10 minus 10, 0. So the required expression finally, that is you may denote it by a capital O or 0. So we have proved a square minus 5a plus 7i equal to 0. So the first result, I am again calling it first, the result has been proved. And it is using this result, now we have to find out A inverse. Now to find A inverse. Now using this result to find A inverse, what do you do? Multiply on both sides to each element by A inverse. So you get A inverse into A square minus 5 times A inverse into A plus 7 times A inverse into I. And now and on the right side also A inverse into 0 matrix. Use certain results. You know A inverse into A or A into A inverse will be the identity matrix by definition. You know. And any matrix, say A inverse or A multiplied by identity will keep it identity, and A inverse with multiplied by 0 matrix will be 0 matrix. So you get on the left A inverse, this A square may be written as A into A. So here I will take one more step. Minus 5 times A inverse into A is identity element. A inverse into identity element will be 7 times A inverse. On the right side it will be 0. And now see A inverse into A is identity element into A as such, IA minus 5i plus 7 times A inverse is 0. Now what about IA? IA will be A minus 5i plus 7A inverse equal to 0. And from here, what is the value of 7 times A inverse? 7 times A inverse, take the other two terms, that is A and 5A on the right side. So you get 5i, A and minus 5i you take on the right hand side. So you get 5i minus A. That is 5 times identity matrix 1 0 0 1. And what is the given matrix A? It is 3 1 minus 1 2. So multiplying by 5 to the identity element, you get 5 0 0 5 minus 3 1 minus 1 2. Subtract the corresponding elements. So you get, and this is the value of, remember, 7 times A inverse. So we get 7 times A inverse, subtract the corresponding elements, you get 2, 0 minus 1 is minus 1, 0 minus 1 will be minus 1 will make it plus 1, and 5 minus 2 is 3. So this is 7 times A inverse. So what is the value of A inverse? Divided by 7, it is 1 by 7 times the matrix 2 minus 1, 1, 3. So this is the required value of A inverse using the result which we proved in 1.